Okay, so we're given the diameter here of the hemisphere to be 2r, which means the all-important value, the radius, is going to be half of that, which is just going to be r. And what's good about that is, with a hemisphere, of course, there's no such thing as a height for a hemisphere. It's just the radius being swept all the way around, yeah? So we know there that that's going to be r there, okay? The radius, okay, which is of course half the diameter as I mentioned. So then we can use that to determine the height of the cone, okay? Because if that is r there, the overall height is 5r, then of course then the height of the cone is going to be 4r, alright? So they say the volume of the toy is 225.8. So I like to start off with that. I like to say, look, the total volume is 225.8. And then what consists of this toy? What creates this volume? Well, of course, we've got the cone, okay? And the formula for a cone is 1/3 pi r squared h, okay, which is given to us on page 2. And then we've got the hemisphere, which is 2/3 pi r cubed. Now that isn't given to us, but a sphere is given to us, which is 4/3, and then obviously the hemisphere then is 2/3 pi r cubed. So what I can do now is I can start plugging numbers in here. 1/3 for the cone, right, times 3.14 for pi, times r squared. Now, the radius is the base radius of that cone, which of course is going to be r, isn't it? Because we've got the diameter to be 2r. So that means the radius is just going to be r. So it'll be r squared times then the height, which now the height of the cone we've just worked out to be 4r. So that's the cone. Now let's go on to then the hemisphere, because these are joined together, aren't they? So let's work out then the volume of the hemisphere added to it. So we've got 2/3 times 3.14 for pi times then r cubed. Well, the radius, remember, of this hemisphere is just r, so it'll be r cubed there. So that'll equal to then the total volume, which is 225.8. And the key is now is just to be careful, work with this carefully, and then we can work backwards then to work out what r is, and then once we've got r, we can get the height of the cone. Okay, so when it comes to this here, what I do is, right, I would times the numbers together here. Okay, in other words, I'll take my time here, I would times these together, because it doesn't matter what order you multiply in, so you can bring the 4 to the front. But you know what's good? I've got r squared there, times r then, which actually makes r cubed. And I do the same here then, 2/3 times 3.14 times r cubed. It's 225.8. So in case then I'm going to my calculator to work that out. So 1/3 times 3.14 times 4, and that comes out to be 4.186 recurring r cubed, plus then, well, 2/3 times 3.14 here, which works out to be 2.093 recurring r cubed, because 225.8. You notice I didn't bother write multiply here or here, because I don't need to. When you've got numbers next to letters, you can write it like that. And then we've got to add these two, okay? So just like algebra, when you add these two, you just literally add those numbers there, okay? So I'm going to do 4.186. Okay, I haven't got a recurring back on my calculator, so I'll just do that, plus 2.093, so loads of them, and then I get that there, okay, actually comes to 6.28 r cubed. Okay, so it stays as r cubed, you're just adding these numbers together. That equals then to 225.8. So then to get r cubed, because of course I'm timesing these, take that over and divide. And then I've just got to do 225.8 divide by 6.28. And I get r cubed out to be 35.9554, blah, blah, blah. So to get r then, I just need to cube root this. Cube root that answer. Okay, because it's cubing taken over cube root. So on my calculator, I'll type that in. And I get r to be exactly 3.3, and then there's a couple of zeros. So 3.3, in this case, centimeters. Now they want the cone height. So remember, the cone height was 4r, so that'll be 4 lots of 3.3, so we get 13.2 centimeters there.